Welcome viewers to the online series of lectures on the course of Introduction to Category Theory. We are on our 8th lecture today. We want to study category theory in an abstract setup. We will also study some examples of categories in the course. But we need to familiarize ourselves with certain structures to do that. So this lecture will be dedicated to the structure of, dedicated to the study of such structures. We'll study graph homomorphism, pre-order, partial order, linear order, and order morphism in this lecture. So we leave monoid homomorphism, group and group homomorphism for the next lecture. Okay. Let us get started with graph. So a graph is a system of vertices and edges that connect those vertices. Okay. So let me formally give this definition along with examples. We start with graph. So here is the definition. And examples. A graph G consists of a quadruple G V, A, SR, C, T, G, T. Okay? So it's a quadruple consisting of two sets and two functions. Okay? Let me explain what those sets are and what those two functions mean. Okay? V is a set called the set of vertices, called the set of vertices of G. Let me turn on another light. Okay, and A is a set, another set called the set of arrows, called the set of edges actually, or arrows of G. Then the third thing that we have to have is a source function and a target function. So S or C is a map from A to B. This is a function called the source function, called the source function for G. Then we have the target function denoted by TGT, which is a map from A to B again, is a function called the target function for G, called the target function for G. So one is source function, another is target function. Okay. So let me explain a little more about these two functions. Given an arrow A belonging to the set A, so there is a set of arrows here, and we choose an element from this set. We refer to refer to SRCA. Sorry, excuse me, small a. Okay. The source of this arrow, and that should give us an element of the set of vertices. Okay. As the source vertex, of A, and to TGTA as the target vertex of A. Okay. So given an arrow, we can refer to SRCA to the source vertex of A and TGTA as the target vertex of A. Alright. So let me give you an example. So I'll give you an example of a graph. Okay. Example. Following is a picture of a graph. Following is the picture of a graph. We already mentioned that graph is a quadruple consisting of two sets and two functions. On those two sets, so now let me draw this picture. The graph is given by what we are going to draw here inside the box. It consists of some vertices. Let us draw those vertices first. 1, 2, 3, 4, and 5. Okay. Let me label the vertices. V, W, X, Y, and Z. There are 5 vertices. Okay? And there is an arrow from V to W in this direction. So let us label this arrow with F. There is one arrow from W to X labeled as G, and there is another arrow from between the two vertices, same two vertices, labeled as H. Right? There is one loop, okay, starting and ending at Y, called I. There is one arrow from Y to Z called J, and there is another arrow from Z to Y denoted by K. Right. So there are 5 vertices here for this graph, and there are 6 arrows. Okay, 1, 2, 3, 4, 5, and 6. So, so we have, for this graph, we have V to be equal to the set, right? V, W, X, Y, and Z. V, W, X, Y, and Z. This is the set of vertices. And we have the set of arrows as well. which is the set A consisting of 6 elements F, G, H, I, J, and K. Alright? Now, we need to mention the other two functions as well. There are two functions here attached to the definition of a graph, and the source and target functions. For this example, the source and target functions SRC, comma PGT from A to V, okay, can be captured in the table. Can be captured in the table below. So we construct a table below to see what these two functions are. Okay. So let me draw this table. Okay. So an arrow is here, A, and there is the source function, and there is this target function PGT. So how many arrows are there? There are 6 arrows, as we can see from this graph: F, G, H, I, J, and K. Okay. For the first function F, what is the source of this function F? See this diagram, okay, and see that F starts from B and ends at W. So the source of F is this vertex B. And the target of this arrow is W. What about G? G is another arrow whose source is W and whose target is X. H is another arrow whose source is W and target is X. For I, which is a loop, the source and target are both Y. Now for J is another arrow for this graph whose source is Y and target is Z. Now for the arrow K, the source is Z and the target is Y. This is how we see these two functions, okay? Alright. Okay, so this was a complete example of a graph. So we get familiar with all the notions of the corresponding sets and the source and target functions with the help of this example. Now, we need to, so in the context of an abstract category, we'll have this notion of product of categories. Okay? So if we give the example of the category of graphs, then we'll have product of graphs as product of objects. Okay? So what does it mean by a product of two graphs? Okay? So in the following example, we see how to construct the product of two graphs. Okay, example where we discuss product of two graphs. Product of two graphs. So it makes sense to have two graphs, to have a product of two graphs. So let us introduce those two graphs first. Okay. First, consider the graph. First, consider the graph denoted by n. For which the set of vertices is the set of whole numbers. Okay. All right. So let me say first what it means by n, because generally I think in the previous lectures we used n as a set of natural numbers, but we are now following Spielberg and we denote n with the set of whole numbers, okay, which includes the number 0. So 0 is in this set. So this set is 0, 1, 2, 3, and all the positive integers. Okay, so n is a graph for which the set of vertices is the set of whole numbers, and the set of arrows is also the set of whole numbers, and the source function is explicitly given by this map, and the target function is given by this map. This is the graph. So this graph can be depicted as okay. So see that the vertices are denoted by the elements of the set of whole numbers. So the first starts with 0, then 1, then 2, and then goes on. And the arrows are also labeled with the elements of the set of whole numbers. So let's check that. Let's check the source function here. Okay. So the input of this map is an element from here, which is of course an element from here, which is of course an arrow, and the source of that arrow is a vertex. Okay. So if we choose 1 here, then 1 is mapped to 1, meaning that the source of this arrow 1 is the vertex 1. Okay? Look at here. The source of this arrow is the vertex 1. And think about this 0 mapped to 0. So these are all for the source function, okay? Source function. So 0 is mapped to 0, meaning that source of the arrow 0 is the vertex 0. Which makes sense here. You see that this is the arrow 0 and whose source is the vertex 0. Okay? Now look at the target. So the target map. It is is given by n mapped to n plus 1. So the target of map 0, or the target of arrow 0, is 0 plus 1, 1. See that this is the arrow 0, and the target of this arrow 0 is the vertex 1. And the target of 1 is the vertex 2. The target of arrow 1 is vertex 2. Okay? So this is how we construct this graph out of this data. Okay? Alright. Now, this is the first graph. So for understanding the product of two graphs, we need two graphs. The first graph is given by this n, and we need a second graph, which we call by g. Let us have the following graph. Denoted by G. Okay, what is that? So there are two vertices. One is A and another is B. There is a loop from A to itself called F. And there is an arrow from A to B that we denote by G. Okay? So this is the graph. Simple graph. Two vertices and two arrows. Okay. Okay. So this graph G, see that we denoting this with our usual quadruple notation. V, A, S, R, C, E, G, T. And for this graph, we see that B is equal to this two-element set, A, B, and A is again a two-element set, which is F on G. Now we need to construct. We need to construct G cross N. Okay. So G is this graph, and the vertices, arrows, and the source and the target functions are given by this graph. And we had this first graph denoted by N, where the sources and vertices and the source map and the target maps are also given there. Now we want to construct the product of these two graphs denoted by G cross N. Let us try to define it. So how do we do? So this is going to be a quadruple again, and this is going to be, so the set of vertices for these product graph is going to be the Cartesian product of the two sets V and N. So the Cartesian product of the two sets of vertices. And the arrows, the same way, the Cartesian product of the set of arrows A and the set of arrows bold-faced N is going to be the set of arrows for this product graph, and there will be source map and the target map that we are going to denote with primes, that is source prime and EGT prime. Okay, so how we are going to define these two maps? That's the question. SRC prime is going to be a map from A cross N, from the set of arrows of G cross N to the set of vertices of G cross N, that is V cross whole phase N, and so is the target map. This is also the map, a map from A cross N to B cross N. So let us define these two maps. Okay, we need some room. So let me erase this part here so that we can write something. I don't want to erase these discussions here. So these two functions are defined in the following way. They are defined in the following way. So SRC prime is going to act on a pair, right? Whose first component will be an element of A, and the second component will be an element of this bold-faced N. Okay? So source SRC prime is going to act on a pair like A comma N, where A is an element of So this source map is going to act on an element of A cross N, and small a is in A, and small n is an element of this set of whole numbers. Okay, and what is it? And it's going to spit out an element of V cross N, which we define by SRCA comma N. Because SRCA is an element of V, of course, because A is an element of, small a is an element of this capital A. So, under the action of the source map of this graph, okay, this SRC is a map from A to V. So this guy is going to be in V, and this guy is going to be in NA. All right. So this is easy to see that this is an element of V cross bold phase N. All right. So now, analogously, we define the target map, which is denoted by TGT prime, acting on A comma N, which is an arrow of the product graph. Okay? And this is defined as TGT of A and N, which is again an element of V cross N. Okay. Well, I think I missed it out. This is going to be N plus 1, sorry. Alright. This is how we are going to define it. Okay? Because the target map for the first graph was from N to N plus 1. That's why we have N plus 1. Okay? Okay. Now, how will it look like? The graph. So, I think we can erase this part now. So, the product graph will look like So, so okay. So let us label the vertices first. Okay. So the vertices are given by this Cartesian product, okay. And n, we know, is the set of whole numbers. So the first element we are going to have is a comma 0, and if we take the Cartesian product of n, the elements of n with this element a, then the next one is going to be 8 comma 1, then we have 8 comma 2, and so on. And then you see that there will be vertices like b comma 1, right? B comma 0, b comma 1, and so on, right? For the second element of the set b. So there will be b comma 0, there will be b comma 1, there will be b comma 2, right? There will be b comma 3 here, and so on. So these are the vertices, okay? So now, so there are two elements for this set of arrows, and so we'll have an arrow called f comma 0, right? F comma 0. Since f is an element of A and 0 is an element of both sides n, we'll have an arrow like this. Okay? And what would be the source of this arrow? So by the definition of this source prime map, we immediately figure out that the source of this guy is going to be SRC F comma 0. And what is source of F? Source of F and the target of F are both A. This is going to be A comma 0. Right? So A comma 0 is going to be the source of F comma 0. And what is the target of F comma 0? By the definition of target map, is going to be TGT F comma 0 plus 1, right? And TGT F is again the same vertex A, since F is a loop, and it's going to be A comma 1. So the target of F comma 0 is A comma 1, and the source of F comma 0 is A comma 0. So this map is precisely this map, which is F comma 0. Okay? So similarly, you can go ahead and find what G comma 0 means. Okay? So what G comma 0 means. So G comma 0 is another arrow there in the product graph whose source, according to the definition, should be source of G comma 0. And what is the source of G? Is A comma 0. That is going to be the source of this map G comma 0. And what is the target of this map G comma 0 is going to be TGT G comma 0 plus 1, right? 0 plus 1, according to this definition. So what's the target of G? Target of G is B and 1. So B comma 1 is going to be the target of this map G comma 0. So I see that this is the map G comma 0. Okay. So similarly, you can go ahead and find the source and target of G comma 1. Let us do it. So we are doing now G comma 1 and F comma 1. So let us try to do F comma 1 first. So the source of F comma 1 is going to be SRC F comma 1 and SRC, the source of F is A. So A comma 1 is going to be the source of F comma 1 and EGT prime F comma 1 is going to be EGT F comma 1 plus 1 according to this definition, and TG2F is the same as A and A comma 2. Alright. So the source is A comma 1 and the target is A comma 2, meaning that this arrow is precisely F comma 1. Alright. Now let's find the source and target of G comma 1. The source and target of G comma 1 will be given by source of G comma 1 is SRC G comma 1, and what is the source of G is A comma 1. That's going to be the vertex, the source vertex of G comma 1, and EGT prime G comma 1 is EGT G comma 1 plus 1 according to this definition, and which gives the target G to be B comma 2. A comma 1 and B comma 2, meaning that this is going to be G comma 1. G comma 1. So this way you will be able to find the other. So we have shown 4 arrows only. You can figure out the other arrows as well. Okay. So there will be. Let me draw another arrow. It will be directed to A comma 3. Not writing it here. We'll just put dots here, and there will be an arrow here as well. I'm going to put dots here as well, meaning that there will be many other vertices along this horizontal direction, and there will be many other vertices along the upper horizontal direction, and there will be the arrows accordingly. Okay, so this is the product graph. So this is how the product graph looks. All right. So now we are on to the graph homomorphism, and let me take a break, and I will start with graph homomorphism in the next segment.